Okay, so for our next step, what we're going to be doing is we're going to be writing conjectures. We're going to be making conclusions based off of patterns, okay? So on the first one, it says that we just need to complete the conjecture, okay? So for a lot of these questions, what we're going to do is we're just going to fill in like descriptors of words, all right? I'm sorry, descriptors of numbers. So that might be something like even, odd, positive, negative, all right? Multiples of 3, multiples of 5, something like that, that would describe the numbers that we're seeing. So it says the sum of any two odd numbers is, and then we have to fill in the blank there, all right, with that descriptor. But it says to show several examples. So the reason why this is a conjecture is that we're only going to do, all right, a minimum of 3 examples, okay? For a conjecture to be true, it has to be true 100% of the time, all right? So the fact that we're only showing 3 examples, the reason why it's a conjecture and it's not fact, all right, is the fact that we aren't doing this for an infinite number of possibilities. We're only looking at 3 examples, all right, and then making a conclusion. So if I break down where it says the sum of any two odd numbers, all right? So I'm going to add odd numbers. So I'm going to start with, let's just do like 1 and 3. So if I add 1 and 3 together, I would get 4. And what I'm looking at is descriptors for that number. And I would notice, well, that's even. It's also positive, right? And so for the next one, I'm going to do another example, all right? But it doesn't say that these odd numbers have to be positive or negative, right? So this time I'm going to add a -5, all right, plus, let's do a -7, and I would get a -12, okay? And again, looking for descriptors of that number, I notice this time that it's even, but this time it's negative, okay? So one more time, let's do one more example, and let's do like 11 plus a -3, and I would get a +8 for that. So we're looking at these sums, all right, the 4, the -12, and the 8, and we're saying, well, what do they have in common? Well, I'm going to notice that they're all even numbers, right? They're all even numbers. And so my conjecture is that when you add any two odd numbers, all right, that sum is going to be even. All right, let's try, let's actually pop down to C where it says now it's the product of any two odd numbers. So this time we are going to be multiplying the odd numbers, all right? So again, let's pick just 2 odd numbers. Let's do 1 times 3. And if I multiply those together, I get 3. All right, now let's multiply, let's do like 2 negative numbers. All right, let's do -5 times -7. And I would get -35. And then let's do -3 times 5, and I would get -15. So if I look at these 3 numbers, again, the conversation is what do they have in common, right? 3, -35, -15. Well, what they have in common is that they are all odd. So our conjecture is that when you multiply any two odd numbers, the product is going to be odd. Okay, so again, minimum of 3 examples, all right, to see what's going on, all right, with those products or those sums, all right, and then you're looking for a descriptor that would match those 3 outcomes. So they're not always that straightforward, all right? So I'm going to look at B and D are going to be kind of tough, to be honest, all right, in order to understand what it's saying, okay? So I'm going to do my best to explain, all right, the best way to think about this. So to actually do this, first of all, it says the sum, so I know that I'm adding something, and it says the first n odd positive integers is, okay? So again, that doesn't make much sense, but what I want to do is I actually want to organize it in a chart. Okay, so let's go ahead. Let's have a long column, all right? And we're going to call this first column, it's going to sound strange, but it's going to be the number of numbers being added. But what really this column is n. Okay, so it's the number of numbers being added. And then this bottom one is the actual sum. Okay, So stick with me on this one. It's not going to make much sense until we get like two examples in, okay? So what I'm going to do is I'm going to add the first, all right, odd positive integer, okay? So the odd positive integer, the first one has to be 1. All right, and that's it. That's why I said it's not going to be super clear. All right, but now let's add the first 2 odd positive integers. So what that means is I'm going to add 1 plus my next odd positive integer, which is 3. And if I add those 2 numbers together, I get 4. All right, let's try the next one. Now we're going to add the first 3 odd positive integers. So I'm going to add 1 plus 3 plus 5. And if I add those 3 numbers together, I get 9. All right, the last one that we'll do, I know I said a minimum of 3, but let's do a fourth one. I'm going to add the first 4 odd positive integers. So I'm going to add 1 plus 3 plus 5 plus 7. I almost forgot there. All right, and then adding those together, I would get 16. So what I'm looking for is a rule or a pattern, all right, that would connect, all right, this column of n, all right, with this sum. So how can I go from this to this, this to this, this to this? Well, here's what I would notice is that if I square that top row, all right, that's going to equal the bottom row, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, but I need to write that as a rule. So if n represents that top row, what we're going to do is we're going to call this rule n squared. So if I wanted to add the first 11 odd positive integers, all I would do is just plug in 11 in for that n, and I know that the sum would be 121. Again, that one's a little bit harder, okay? This last one in this set is going to be very similar to that one, all right? And we're going to try it again, all right? Where it says the product, so I'm going to multiply, of the numbers n minus 1 and n plus 1 is. Okay, so let's go ahead and look at this example, all right? Okay, so let's go ahead and call this first one n. All right. And then down below, this is going to be n minus 1 and n plus 1. Okay, just give me 1 second. Okay, so what we're going to do is we're going to pick numbers that we're going to substitute in for that n. All right, so I'm going to take 1 and I'm going to plug it in, okay? So I'm going to take that 1, I'm going to plug it in for here, and I'm going to plug it in for here. And then I'm going to multiply them together. All right, so 1 minus 1 is 0 times 1 plus 1, which is 2, right? Now, if I multiply those together, I actually get 0. So that's not super helpful, okay? Let's pick another number, though. All right, so let's say 2. So if I plug that 2 in, I'm going to have 2 minus 1, which is 1, times 2 plus 1, which is 3. So multiplying those together, I get 3. All right. Let's do 2 more. So let's take a 3 and plug it in. All right. So 3 minus 1 is going to give you 2 times 3 plus 1, which is 4. And I'm going to get 8. Last one, let's plug in a 4. All right, so let's do 4 minus 1, which is 3, times 4 plus 1, which is 5, and I'm going to get 15. So just like that one up above, is there a connection that you guys can see between these 2 rows? All right, is there any way that I can write a rule that would represent, all right, how I can go from that top row to the bottom row? And I can. So the rule is actually going to be n squared minus 1. Right, meaning that if I take that n and I plug it in, 1 squared is 1, minus 1 is 0. 2 squared is 4, minus 1, which is 3. 3 squared is 9, minus 1, which is 8. And 4 squared is 16, minus 1, which is 15. And so that's my rule. All All right, I'm going to pause here, and then we have one last little bit, all right, before this lesson.